Friends, we will continue with the discussion on explosion and fire protection. Lecture 42 is a continuation of the last lecture, where we discussed to start about the explosion and fire protection methods. As referred in the last lecture, we said that offshore platforms are generally equipped with platform support vessels. It is very important that the platform support vessels should be ensured thoroughly of fire protection, because if these PSVs are not saved and supported under fire, then rescuing of the platform or fire protection to the platform will become a big challenge. Therefore, we understand and agree now that PSVs should be protected in case of fire. Because we agree that if there is fire in PSV itself, and not managed, it can become very difficult to protect the platform. Subsequently, then the question comes, how do we actually design a fire protection system for PSVs? It should be integrated with the geometric design of the platform. Fire protection system design should be a part of the platform layout itself. What does it mean is that all potential hotspots in the platform layout should be enveloped into the fire protection layout. What are the common types of fire protection? Used in offshore platforms. Let us ask this question and look few more details on this. The foremost system which is commonly used in PSVs as well as in offshore platforms is foam systems. These kind of systems are very highly suitable for hydrocarbon fires, there are three types of foam systems, namely low expansion system which is suitable for storage tanks, heli decks, loading terminals, etc. The second variety is medium expansion systems, which are mainly useful for transformer protection. The third type is high expansion systems, which are highly applicable for LPG spills. So, friends, under the foam system category, you will see that for electric fire and short circuiting fire, people generally use medium expansion systems. Foam systems essentially contain air filled bubbles which are formed from aqueous solutions. The density is so low that it is lower than the lightest flammable liquid, so that they can fill up in the spaces very easily and can do effective fire protection. The commercial brand available I am just quoting an example is Nosley SK, which is Trafford Park, Manchester, UK. That is one classical brand available in the international market, who does design and development of foam systems for fire protection design in PSVs as well as in offshore platforms. The next type, which is commonly deployed, is high pressure water mist. As we said in the last lecture itself, that we should actually use potable water for fire protection. One of the main reasons is sea water is very corrosive. It may spoil the machinery and it may be harmful to human on board. So, in high pressure water mist system, potable water is sprayed at a very high pressure. These systems are specially suitable for platform support vessels. The main advantage of the system is PSVs can remain functional even during such fire protection applications. So, that is one of the advantage of this kind of system. The commercial brand available in the market of this system is high fog, which is from Finland, and the other brand is Semco Maritime, which is essentially from Denmark. Let us discuss more in detail about explosion protection. Friends, when prevention of flammable mixture is not possible, this is a classical example where we are dealing with exploration of hydrocarbons. So, during exploration, of hydrocarbons, it is practically not possible to avoid flammable mixture. So, when presence of flammable mixture is not possible, then explosion protection systems which is briefly said as XP systems, explosion protection systems, need to be installed and integrated with the platform layout. There are three types of common XP systems which are practiced in offshore installation. One is containment system, other is suppression system, and the third one is venting. All the above protection methods, all above XP methods will and should protect the PSV and the platform from rupture or any such catastrophic failure but damage will be there to the internal appurtenances of the PSVs which cannot be protected. So, friends, please realize and understand that even when explosion protection equipments are installed in the layout of the platform itself and they are automated, damage to internal appurtenances is unavoidable. Out of these three methods of explosion protection, containment method, and suppression method. Prevent also the discharge of unacceptable material into environment. Therefore, under the recent environmental bylaws which are applicable to offshore production facilities, containment method and suppression method of explosion protection devices are strongly recommended and urged to be practiced in offshore platforms as well as for PSVs. In the containment method of explosion protection, it is actually designed to withstand high internal pressure. It means vessels are designed what we call as containers to withstand high internal pressure as a part of the design itself, and this pressure will be at least 4 times of working pressure. As a precautionary measure, the containers are designed to withstand very high internal pressure, and that method of design is what we call as containment method of explosion protection. National Fire Protection Association recommend detailed design procedures for explosion protection of PSVs and container vessels. So, detailed design methods and control applications are recommended by NFPA, which are exclusive for platform support vessels and platforms itself. Explosion suppression is a very interesting technique in which a suppressant is discharged into the exploding medium to stop the combustion process. Now, to decide the point of supply of suppressant, into the exploding medium, the system design is fitted with pressure and optical detection systems, which are nothing but type of sensors. These sensors will command the time of intervention of the suppressant into the exploding medium, which will then subsequently retard or stop the entire combustion process. So, we call that as explosion suppression systems of explosion protection design. The next one what we have is deflagration arresters, which are very commonly used again in PSVs. There are two types of arresters. One is end of line arrestor, two is tank vent arrestor. Please note that these arresters do not stop detonations. But they only control them. So, they actually reduce the risk of flame propagation. That is the main function of deflagration arresters. In addition to this, we also have many active safety measures apart from the passive systems what we so far discussed. There are active safety measures to control overpressure, which results in explosion. There are basically 4 methods of active safety measures, namely pressure relief devices, safety relief devices, pilot operated relief devices, emergency shutdown valves, and ruptured discs. Friends, being engineering graduates and practicing professionals, you would have heard and come across many type of pressure relief devices, pressure relief valves, safety relief valves, pilot operated relief valves, and ESVs, emergency shutdown valves. So, we will not discuss them in detail about the mechanical layout and the design concepts of these valves and devices. However, ruptured discs are quite interesting and different, which are commonly also deployed as an associate devices along with these above 4 methods of active safety measures. We will discuss them very briefly here. We know pressure relief valves open gradually when there is a pressure build-up in the flow line. Actually, the primary function of this type of device is to control hammering effect. Yes, hammering effect is one which can actually cause damage to the pipeline, which is of a very catastrophic nature. They are very useful in liquid flow lines. The common one used again is a pop-up valve or simply pop valves. They are also kind of pressure relief valves. But used in gas or vapor flow lines. The interesting allied part is the rupture discs. They are designed to burst under high pressure. That is why they are called as rupture discs. It consists of a thin circular membrane which is generally either metallic or plastic by material. The disc is clamped to the holder. In the process, when the pressure builds up, when the pressure builds up, the disc ruptures and relieves the pressure. Interestingly friends, it has got a very important negative consequence. The positive part is it relieves pressure and saves the flow line from any further damage, but the negative consequence is discs cannot be reseated. So, it is kind of a destructive system which is consumed during the process of firefighting or fire protection. It cannot be reseated once it is ruptured. Secondly, and most importantly, the entire content of the upstream side will be vented. So, you lose the entire pressure buildup available in the line, whereas the other kind of devices what we just then saw, they will control the pressure and regulate the pressure flow, but it does not vent off the content, whereas in ruptured disc the entire content of the upstream side will be vented to atmosphere. Under these discussions, we have realized that explosion is not far away from blasting. So, we should now discuss more interesting part on blast resistance as a part of explosion protection. Blast resistance involves the following: 1, quantifying the blast overpressure, which is responsible for explosion. 2, establishing the design blast loads based on the blast overpressure, which is quantified. Thirdly, setting the performance requirements of the structural members of the platform. Please understand, blast resistance cannot be directly applied to non-structural members. Of course, blast resistance can be applied to protect machineries and equipments, but machinery and equipments cannot be designed to be blast resistant. You need to have some passive cover which encircles the equipment, and therefore, the equipments are protected. So, we must also set the performance requirements of the structural members of the platform, and lastly, designing the structure to withstand blast overpressure, within the platform performance limits. So, friends, in this lecture we extended discussions on explosion. We also discussed about explosion protection systems, their necessity, their layout requirements, their objective, and various commercial brands suitable for PSVs. We discussed about platform support vessels and their explosion protection methods. We also discussed about some note on blast resistance with reference to overpressure which can arise during explosions. Thank you very much.